In this module, we've been talking a lot about algorithms and abstractions and how we can express algorithms and how we can use algorithms to think more powerfully and elegantly. So in this specific video, we're going to talk about something called pseudocode. And pseudocode is a way of expressing ideas and expressing code without actually using a specific language. And it's very language independent. It contains examples of things that appear in each language, but there's no specific syntax to it. So for example, we're going to use the concept of if, which we've talked about in controls. If something happens, then you do this. But we can express it in a way that doesn't tie it specifically to a particular language. So we're going to talk about that with some examples, and you'll see what we mean. In this video, in order to understand pseudocode, we want to stick with an example. And so I'm picking an example that I hope that you've heard of. It's a game called Tic-tac-toe. At least that's what it's called here in the United States. Other parts of the world, I've heard that they call it noughts and crosses. So in case that you have not heard of it, let's do a brief review. Tic-tac-toe is a game that's played with 9 squares. They're generally numbered 1 to 9 if you're doing them on the computer, which is the example that we'll look at later. But you've got 9 squares, there's a 3x3 board, and you can draw in alternating turns. It's a 2-person game. You draw either an X or an O. So let's imagine that you're the X. Your goal is to get 3 X's in a row, either in a row or in a column or across a diagonal. And O's goal is to keep you from doing that while trying to get 3 O's in a row somehow. So in order to write out some pseudocode for tic-tac-toe, we need to consider what exactly a tic-tac-toe player should do. And I want to mention at this point that the reason we're sticking with tic-tac-toe, in addition to it being simple, is actually that your project is going to be on tic-tac-toe. So you're going to be eventually writing a tic-tac-toe player up. So let's talk about what it means to play tic-tac-toe and what it means to play it well. Can we list out some rules? Let's start with rules before we get to pseudocode. So what are the rules of a winning tic-tac-toe player? Keep in mind that we're not necessarily going to write the optimal tic-tac-toe player. I just want to make some quick rules, sort of that you could write a player that would not be horrible. So the first rule should be, if there is a win, do it. So if you can win, make that winning move. If your opponent's about to win, clearly you should block your opponent's move. How about, it's always good to start in the center square. And if your opponent didn't start in the center square, that is to say it's now your turn and the center square is free, then play in that center square. So now if you filled in the center and you clearly aren't about to win, what should you do next? Well, how about if a corner is free, and particularly if a corner is free that's in line with another mark of yours, an X or an O, whichever one you are, or if you have the center, then you should play in that corner. And finally, if you can't make 2 in a row, which is what we were aiming for with that corner, then just play in an empty square. I'm sure there's a more smart way to talk about which empty square you should pick, but without talking about how to do the optimal strategy, we're just trying to make a player that's not horrible, then just play in the first empty square that you find. This set of rules won't give you an optimal tic-tac-toe player, that is, one that would play optimally against another tic-tac-toe player that's playing optimally, but it will give you a player that's not horrible. You certainly don't want to play against a random player. And so it's going to be the set of rules that we work from for this example. So now let's talk about how to turn these into pseudocode. So in order to turn these rules into pseudocode, let's consider that we're going to call each one of these rules probably a helper block, or just a block that can be called within another block. And we've already talked about how to make a function or a block. So let's imagine that there is a block called find next move. And within find next move, it's going to call each of these different helper blocks. So to start with pseudocode, let's start with the very first one, which was, if you can win, do it. How do you know if you can win in a tic-tac-toe board? Well, the way you can do that is if there's 3 in a row, that is any one of the rows, or 3 in a column, or 3 diagonal. And we could hard code the winning positions just to see if there is a winning position on the board, and that's fine. But in order to check to see if you can win, that is, that you're 1 away from a winning position, we're going to write a little bit more of a general function, and we're going to talk about that now. So let's focus on that function. Let's call it that function, or that block as it's called in Snap. Let's call it find winning move, and it's going to take an input. And that input is going to be a player. And so the way that we're going to express that in pseudocode is to say the function name, the find winning move, and we're going to use parentheses and then put in what the input is. And so we're going to call that player. So when you write pseudocode, typically you also write something about what the function does and what the function takes as input. And the way that you do that is to use comments. The typical comments that are used in pseudocode are // and they just mean that whatever's in there is just a comment, it's a notation, it's not intended to be turned into code. So the first comment I would say about this function is that it's going to return a move, and the way that I'm going to represent this is it's just going to return a number from 1 to 9, and if it can win, or it'll return -1 if there's no winning move. And the second comment that I would make is to note that the player, that parameter that's coming in as player is either going to be an X or an O. That way you can just compare it directly to what's in the board. So the first part of the pseudocode, we're going to consider looking for X's or O's in a row. And by a row specifically here, I mean the horizontal rows. So the way that we're going to do that is we're going to look at something through a for loop, and I'm going to loop through a variable that I'm going to call row. And instead of just bringing it up in Snap, the way we're going to represent this, we're going to use the for that we used in Snap, which is representing a for loop. I'm going to declare a variable called row just by saying for row equals, and then I'm going to tell it what its range is. And it's going to range from 1 to 3. And when you see pseudocode, you'll see various ways of expressing this. The way I'm expressing it is just to use the word 2. So it starts at 1 and it goes all the way to 3. So in order to determine how many X's or O's there are in this row, I'm going to declare a variable called num in row. And when I declare it, I'm just going to initialize it to 0. That is to say there's nothing in a row at the moment. And then I'm also going to be looking for blanks because it's important. Remember, the function that we're writing is find winning move. We're not looking to see if there is a win. We're looking to see if there is a move that we can make as a win. And that is, we want to find 2 in a row with a blank so that we can fill it in. So I declare a variable called num blank, and I'll just say num blank equals 0. And then I'm going to make a column variable called blank column, and that just tells me which column it is that it is blank, so that at the end you can say exactly where the move is. And now I'm going to loop through the columns. So for column equals 1 to 3, let's look at the move at that entry. So at the entry row comma column, is it that player? And we're just going to say that by if move at row comma column is player, then we increment the number that are in a row. And the way we're expressing that is something that you haven't seen before in this course. We're using the expression plus plus, and that means increment that variable by 1. So another way you could say it would be num in a row plus equals 1, which is another way to say you just equal the same thing plus 1. Or you could say num in a row equals num in a row plus 1, but plus plus is a much shorter way of saying that. So now that we've incremented num in a row, we've said, okay, we've had the move there is the same as this player. Now we need to look and see if it's empty, because if it wasn't player, the next choice is it's empty. And if it's empty, we're going to increment the blank variable with num blank plus plus. And we're also going to note what column this is. So we're going to save that. Blank col equals the column that we're in. And at the very end, for this row, after you've gone through the columns, you're going to check something. And the way we're going to say that is if num in row is equal to 2, so the equal is a test rather than an assignment. A single equal is an assignment. So if num in row is equal to 2, and the num blank is 1, then we're going to return that row and that column, because it tells you that there were 2 in a row somewhere in that row for this player, and there was a blank in between. So if the check for a winning move in rows didn't work, then the next logical thing to do is to look for a winning column. And it's exactly the same logic, except for we're going to swap the idea of the rows and the columns. So here we're going to loop through the columns. So for column equals 1 to 3. And we're going to initialize the same variables, except for we're looking at columns instead of rows. So number in the column is 0, number blank is 0, and then the row that we're looking at, the blank row, is now 0. And we're going to say for row equals 1 to 3, so that is we're going to look at each individual row. If the move is at that spot, row comma column is the player, then we increment the column, num and col plus plus. And if the move is empty, we increment blank, num blank plus plus. And we need to save that row if it is empty. So we say blank row equals row. And then we do the exact same check that we did for the row with the columns. We now look to see if there are 2 in a row, that is num in column is 2, and there's a blank. So num blank equals 1. And the way we express that in the pseudocode, if num and col equal 2 and num blank equal 1, then we're going to return that winning move, which is blank row comma column. So if you didn't find a winning move across the rows or across the columns, you need to check the diagonals. And the way that we're going to do that without a nested for loop, because there's no reason to nest this one, is to just look at the diagonal. And we'll start with the left-hand diagonal, the one that goes 1, 1, 2, 2, 3, 3. And then we need to check the other one, which is 1, 3, 2, 2, 3, 1. So let's look at that first one. And we're just going to say how many of them are that match this player, and how many, is there another blank in there. So it's pretty much the same as we've been doing, except for instead of saying num blank or num in row, I'm just going to keep a variable called num. Initialize that to 0, the number blank is 0, and say which one it is that is the one that's empty, and I'm just going to call that blank as 0. And I'm going to look through the 1, 1, 2, 2, 3, 3, and the way I'm going to do that is to say there's a for loop that is for row and column that both go together from 1 to 3. And look and see if the move at 1, 1, for example, is the player, then you increment the num, And if it's empty, you increment the number that are blank and you save a pointer to that row. You say blank is row. And then at the very end of that check, you say, well, were there 2 of that player? If num equals 2, and 1 blank. If num blank equals 1, then return that. In order to make this work for the other diagonal, you just need to switch your logic so that you check the first row, the third column, so 1, 3, 2, 2, and then 3, 1, and you do the exact same logic. At the beginning of this function, we said that we were going to return a number from 1 to 9 or a -1. Now we've done something slightly different with this function, so let's talk about the -1 first. The way that we're going to do that is just put it into the pseudocode and say, okay, if we didn't find a winning move across the rows, the verticals, or the diagonals, then let's just return -1 at this point. But I'll note that actually what we were returning instead of a number from 1 to 9 was actually the row and the column. And so what I would do at this point is actually just go back and fix the comment and just say that we're going to return a row and a column if there's a winning move, and otherwise we're going to return a -1. That was a lot of pseudocode, but hopefully it's given you an idea of what pseudocode is and how you can use pseudocode to powerfully express your ideas in a language-independent manner. So now let's take that pseudocode for find winning move and move back to pseudocode for the idea of find next move, and that is take our entire set of rules that we talked about at the beginning and talk about how to turn those into pseudocode. So let's call this block or function find next move, and it's going to take a parameter of player, and again the player is either an X or an O because it needs to know who it's finding the next winning move for or the next move for. And if you recall, our first rule was to find a winning move. So the thing we're going to do for find next move is say call find winning move and see what it returns. So we're going to express that with if find winning move of that player is not equal to -1, and the way I'm expressing not equal in this particular version of the pseudocode is bang equal. You could do it with an equal with a line through it as well. If it's not equal to -1, then return that move. And if you recall, what we're having it do is either return a winning move or return -1. And so we're checking. If it's equal to -1, then we want to move to the next rule. And if it's not equal to -1, then we want to return that winning move and make that move. The next rule was, can your opponent win? Well, we better check that too. So the way we do that is just to check if find winning move on your opponent, that is the player that is not you, is not equal to -1, then you want to return that move and block your opponent. Our next rule was if the center square is empty, so we're going to imagine that that's another block that we've written, and it's a pretty simple block. You just look at the center square and say, is it empty? If it's empty, return the center square, and if it's not empty, then you're going to return -1 or something and not do it. And now we're going to look at the corners. Well, there are only 4 corners, so we can just have a little for loop that loops through the corners. 1, 1, 1, 3, 3, 1, and 3, 3, and say if that corner is free, then return it. And finally, since we weren't making the optimal player, we're just going to say, okay, we didn't find a move up to this point. Let's just, for each number from 1 to 9, look for the first one that's empty. So is 1 empty? Return it. 2 empty? Return it. So basically the way we're going to write that in pseudocode is for each square in the board, return the first one you find that is free. So pseudocode is really important for being able to express your ideas logically and powerfully. And another thing it's really helpful for is helping you to think through your ideas and your algorithms before you actually implement them and create bugs potentially. So you write them down, you look at it, and you say, wait a minute, that doesn't look right. And so as you're writing down the pseudocode, you can work your way through the logic and hopefully find those bugs before you write them into your code. It's possible that the way that we wrote find winning move isn't the simplest way to do it, and I challenge you to go ahead and write a much simpler one. Go ahead and think about it, write out the pseudocode for it. That would be great. The next lab is going to be the final lab for the course, and it is going to focus on tic-tac-toe because it ties together everything that you've learned. And so go ahead and use the pseudocode and use the idea of expressing pseudocode to make that lab work really well.